economy. Thanks, everyone. You can go to the chat to see a little bit of who's here and where they're tuning in from and the kind of work that they're doing. Without further ado, let's get started. I'm really excited to introduce Ashley Kosak from FracTracker Alliance for the presentation, Greenwashing Hydrogen, Understanding the Climate Risks of Blue Hydrogen. My name is Ryan. I'm with Halt to Harm Network, and my role here is to provide some technical support. So if anybody has any questions or needs anything, please reach out to me in the chat. I have just enabled closed captions. You can turn them on or off using the Zoom toolbar as well. And as I mentioned before, we're recording this session. We'll be posting the replay in Halt to Harm Network. I'll post a link to where you can find the replay in the chat before the session is over. Halt to Harm Network is a place for people around the US to connect with each other around the work that we're all doing to protect our communities and environment from oil and gas. We have a recordings archive, we have an events calendar, we have discussion spaces, and a directory of almost 400 members of Halt to Harm Network that have taken time to create a profile. So I invite you to do that, and I'll put all the links in the chat. Okay, thank you. And Ashley, take it away.
Cool. Hello, everyone. I used to have a joke about hydrogen that I'm not sure if it still works anymore. Well, inflation, I don't know. I was gonna say that the issue with hydrogen right now is inflation. LOL, but that's actually more a little bit about helium. Anyways, hi, my name is Ashley Kosak. I am a program management and research fellow with FracTracker Alliance. FracTracker does data and mapping of ongoing like fracking projects and oil wells and pipelines that exist within, I think within the US, but also I've seen some like info about international. So I don't think that they're limited just to the US, but really part of the goal is that through providing this data, it can aid in passing legislation. It can aid in changing regulatory standards. One recent win was adding setbacks to California for 3,200 feet. I'm gonna get the number wrong. But yeah, they've been a wonderful group. And so I joined FracTracker back in August as a fellow, and now my fellowship's coming to a close. And really what I did was I spent the last couple months like really trying to deeply understand hydrogen and distill this information in a way that could help other people understand it too, because I think that this has been a growing topic within like the climate space, but also within like the energy space. The US government is putting a lot of funding towards it at the moment, and like ultimately there's a lot of movement towards using hydrogen as a clean burning fuel. And so I want to talk about that and help other people understand the process that exists out there. And so I guess, so that's a little bit about my introduction. My background is in mechanical engineering. I went to Rochester Institute of Technology, and then I went on to work at SpaceX, where I was a propulsion engineer. I was a propulsion engineer for 4 years. And I worked on the launch site as well as integrating the crew capsules. And now I have my own company, and so that's what I'm doing next. So with that being started, what is hydrogen? So we're all familiar with the periodic table of elements. Hydrogen is the smallest atom that is on the periodic table. It is one of the most common gases on the planet. H2O uses it. H2O uses it, CH4, all these different elements that I'm going to break down a little bit further. But really what I want you to be able to see is that hydrogen itself, because it is such a small atom, it has this tendency to leak. It wants to escape through things. So like imagine a balloon, and that balloon uses helium, which is on the other side of the periodic table. Similarly, a very small molecule. And when you put that helium into a balloon, it's going to eventually seep out through any of the, through like the plastic that encases that balloon. And so that sort of showcases, like, when it comes to elements that are that have atoms that are this small, they want to escape. They're going to distill out. And so that's where some of my initial concern with hydrogen started. Was I was like, wait, you guys want to use hydrogen as a fuel, but it is an extremely leaky substance. So how do you plan to do that? So there's a few different uses of hydrogen. It's been used as a rocket fuel. It can be used in welding as a shielding gas. It's used in hydrochloric acid. Liquid hydrogen is really important in the study of superconductivity, which I think is pretty cool, because especially if you use superconductivity to build a high-speed rail, then that means you lower some of the friction that could otherwise take some of the energy out of that system. So liquid H2 gets used for that as well. You can see an example of the levitation that's caused by that over on the right. And that's also been used for transportation in the past too, more notably the blimp, which honestly worked until it didn't. And so, oh well, blimps, but they tried their best. And then you can see on the right, the Delta IV heavy engine. This is one of the engines this is one of the rockets that launched down Cape Canaveral. And so it utilizes hydrogen as a fuel and oxygen as a gas. And that sort of like fire triangle of like ignition source and heat plus hydrogen as a fuel and oxygen as the gas allows for you to get a launch. So the space industry uses hydrogen pretty significantly too. So let's talk about the hydrogen color wheel. Hydrogen, as you may have seen, has been getting a pretty significant amount of branding around it when it comes to blue hydrogen, green hydrogen. And I think the reason why there's all this branding around like the colors of it is because it sort of helps people understand like helps people understand that it's coming from a different place than where hydrogen has traditionally come from. I also think it makes it easier to avoid some of the harder questions if you can just point at like a simple name for hydrogen instead of the actual use of it. So as far as like hydrogen goes, there's all these colors. Black hydrogen is coal gasification. Gray hydrogen comes from fossil fuels. Green hydrogen comes from renewable power, meaning that the power that goes into that system is coming from renewable sources. And then the molecule that they break down in order to receive that hydrogen is actually water. So you put water in, you create a steam, you get hydrogen out. There's blue hydrogen, which uses methane gas, same as gray hydrogen, those fossil fuels, but in addition to carbon capture and sequestration, which, especially as a climate network, I'm sure we all have some thoughts on it, but I'm going to break that down a little bit further too. Teal is methane pyrolysis. So again, another fossil fuel source. Pink or red is nuclear power hydrogen, and then white is naturally occurring hydrogen. Not all hydrogen is created equally, but the emissions are. So what I wanted to show here is that even though there's all this movement right now towards hydrogen as using blue hydrogen or green hydrogen, a majority of the hydrogen that we currently have in our existing infrastructure is coming from coal gasification and fossil fuels. No carbon sequestration. There really aren't any successful carbon sequestration demonstrations yet. And so over 90% of hydrogen is coming from non-renewable sources and coming from carbon emitting sources. And you can see that on the right, like gray hydrogen, that's just fossil fuels, and the blue hydrogen without the gas capture only has a very small decrease in the overall carbon emissions that it creates. So what we're seeing here is that even though there's industry movement towards this alternative method of creating hydrogen and making it more green, overall, it's actually still emitting a pretty significant amount of greenhouse gases, carbon. And so it makes you wonder, especially if it's emitting more methane as a result, why are we moving towards this? What are we doing here? So let's talk about how gray hydrogen is made. I'm going to break this down a little bit further. So my background's in propulsion, like I said, and I love a good schematic. I'm going to try to walk you through the schematic as straightforward as possible, and I've included some animations to help out too. But really what you see is you've got your inputs on the left. So you've got methane and water. water molecule and methane molecule. So a water molecule has 2 hydrogen atoms and 1 oxygen atom, H2O. Methane uses CH4. So that's 1 carbon plus 4 hydrogens. So that CH4, that methane, that's being used as a fuel to heat up this chamber to over 700 degrees Fahrenheit to perform or steam reformation of hydrogen. So you put this methane in, you inject water as well, and through heating this all up, you end up with this separation of molecules that allows for you to harvest those hydrogen molecules and emit a carbon molecule as well. I'm just going to say off the bat, this is pretty much the extent of my chemistry understanding. I took 1 chemistry class in college, and then they asked me to take another science elective, and I took science of the garden. So, you know, maybe the numbers of all of this isn't going to work out totally well. Like, I'm sure that there are like 3 hydrogen molecules for every like 1 carbon oxide molecule. But just to make this simple, this is really like the type of process that we're working with here. So those hydrogen molecules are then going to go into the storage chamber for hydrogen, and then they can be transferred to whatever vehicle they're going to be used for. And then that carbon monoxide is actually going to go into a smokestack. So when we talk about blue hydrogen, really it's that same process, but now you've added a little carbon capture at the top. And so I think this really helps break down like why blue hydrogen is kind of not passing a sniff test right now, because carbon capture itself isn't necessarily a viable technology at the moment. And while there's efforts towards it, it would require in order for this to be in any way successful, it would require that this carbon capture is 100% foolproof, where unfortunately that has not been successfully demonstrated quite yet, especially in this country. So blue hydrogen and gray hydrogen, they use the same inputs and they ultimately have the same outputs. The difference between those outputs is that that carbon is going into carbon capture and sequestration. And now you also have to figure out where is that carbon capture going to go. And that could be a whole different presentation. So I'm not going to break it down too much right now, but that's what I want to point out is that it's really reliant on this unqualified technology, a technology that isn't necessarily scalable, and yet there's a lot of momentum towards like creating this. So when this hydrogen is produced, it's going to go into a car. That's the ideal case, or not ideal case, but that is one of the end uses for it. I want to help you understand that too, because recently I've been seeing more Toyota Mirais on the road. I've seen one Hyundai Nexo so far, and this is part of what I think is driving some of this movement towards hydrogen, is that the automotive industry really would like to not only receive more funding for development of new vehicles, but they can point towards this as their method of going green, even though this technology hasn't necessarily proven itself to be green. So within a hydrogen fuel cell vehicle, you've got a hydrogen tank. It goes into this fuel cell, and I'm going to break that down a little bit further through the process of reaping the electrons from that hydrogen. Those electrons go into the battery, and then that goes to your electric engine. And so at the end of the day, really what you're doing is you're taking that hydrogen, converting it into electricity, and then that electricity is going into an electric engine. Oh yeah, I'm going to talk about that too. Don't worry about that. And I think like one of the criticisms I have about this is that we already have electric vehicles that are on the grid, that are on the road right now, that are being scaled, and they already have built up quite an infrastructure for charging, whereas hydrogen doesn't have that same infrastructure, but there's still movement towards making cars that are dependent on it. So how does a hydrogen fuel cell work? Let's do a little bit more chemistry. And I do have more animations too. So you're going to put your hydrogen in. Those hydrogen molecules have 2 electrons. This is an H2 molecule. And those electrons are going to go into your anode. Basically, what I learned in chemistry as like a little mnemonic device is the flow goes from high to low. So you go from like a high voltage to a low voltage medium, and that's going to want to pull those electrons. The movement of those electrons is what creates electricity. So electrons are going to be pulled away from the hydrogen atom. Those electrons are going to travel through what ends up being that battery that you saw in the previous slide. And then those electrons end up in the cathode, which then can help bond hydrogen. So hydrogen, being such a small gas, is going to seep through that electrode. This is oftentimes platinum. This is something that this is usually like a rare earth metal that wants to hold onto hydrogen. And through putting in oxygen as an air intake is actually going to cause a chemical reaction which emits water, H2O. And so that's why when you see in hydrogen fuel cell vehicle commercials, they're saying that the output is water. It's such a clean burning thing. You don't have a carbon output because the only output from this process is water. But what they're not pointing out is leading up to that point is all of the emissions that came from that smokestack, all of the emissions that came from creating that fuel that is going into the process of creating hydrogen. You end up with a more inefficient process. And really the question is, why would we take something that has energy, put it through a process to create a different gas, and then use that gas to create electricity, and then use that electricity to power a vehicle? Like, it's sort of like, how are we deriving so many steps away from the base elements that are being used here? So let's talk about the challenges of hydrogen production as well. For this to be a viable technology, you need a nearly perfect sealing of lines and tubes, and you need perfect carbon capture from the process. In addition, there's no experience storing carbon long-term from carbon capture. In the best case, in the best case of, I messed this one up. The overall carbon footprint, so like life cycle analysis versus emissions life cycle, meaning that you're looking at the full process of all of the materials that had to go into it, all of the machinery that had to go into it, everything that you've bought for that process. Your carbon footprint accounts for all of that. And when you look at that, that actually ends up with a higher carbon footprint than alternative methods of fueling production, meaning even just taking methane and burning it would be a lower footprint than the process that is being used for creating blue hydrogen. And it requires more natural gas, which I think points to some of the motives in the industry, especially because there's a lot of traction within the community to finally decarbonize and remove ourselves from oil and gas. In a way, I think this is pointing towards the oil and gas industry trying to provide a patch solution and avoid the question of, well, where does the hydrogen come from? If you can just point at it as a color, it's a little bit easier than saying, well, we're going to make hydrogen using gas and we're going to capture the carbon with an unproven technology. And one thing I also want to point out is, so like I said, I used to be a SpaceX engineer, and a lot of my work was in propulsion, meaning that I would install the tubes, or I would work with the team who would install the tubes. We would then flow hydrogen and nitrogen through those lines to check for leaks. And the issue with leak paths is you can see a small crack right here allows for hydrogen to escape. And it's a tiny, tiny molecule, so it wants to escape. Any flange like this, any place where there are two sealing surfaces that are interacting with each other, think of like an O-ring or something. You want to like compress those sealing surfaces so that nothing can escape through it. However, with something like hydrogen, it is so easy to escape that you are talking about a nearly perfect sealing surface. And that means that you have to go through and you have to polish it. You need to create redundancy in the process. And you also need to create a process where you can analyze for leaks and verify that there are no leaks coming from that system. Yeah, you can see right here, there's a hydrogen analyzer. So this is one of the ways that they can sniff for hydrogen. but this is like an extremely manual process. There are some sensors out there that can do this as well, but hydrogen is such an abundant source of gas within our atmosphere that it can also flood those sensors. So there's a lot of work that has to go into detecting the leaks for something that is extremely leaky. So there are a lot of companies out there trying to shape this narrative as well. This is from Woodside Energy. This is how simple hydrogen is oh, it's just natural gas. It's going to be CO2 management. And then hydrogen is just born. And now it's going to go into your zero emissions transport, industrial chemicals, all these things. So I think a lot of the energy companies out there are trying to make this seem as simple of a process as possible so that people don't have to look at what it is actually like how the sausage gets made when it comes to hydrogen. Green Biz said, is green hydrogen the biggest opportunity for climate tech funding? New law provides hydrogen's biggest boost yet from Yale Climate Connections. Natural Gas Intelligence says that Pennsylvania's planned blue hydrogen hub will drive the mid-Atlantic energy transition. And ABC News said, what is green hydrogen? How is it made? And will it be the fuel of the future? And a lot of this publication is being driven by marketing agencies that are working with oil and gas. So I just want to point out, I guess, like the reason why I point this out is because the narrative around this is shaping what the venture capital world looks like. This is shaping how investments are going. So I've been working within like the startup space now for about a year, and hydrogen companies are on the rise. So even hydrogen startups are emerging left and right, and they are getting millions and millions of dollars of funding. And sorry, I'm going to skip that slide. I'm going to go back to it. They're getting millions of dollars of funding, and the US government is also putting a lot of funding towards this as well. So as far as policy goes, the IRS is providing $3 per kilogram of carbon captured for specifically this technology. There's $8 billion in funding for new hydrogen hubs through the infrastructure bill. There's $3 billion in funding for ultra-efficient vehicles, which are the vehicles that I showed you. And that also includes $55.1 billion in loans for companies to build new facilities for this. On top of that, $5 billion are being allocated towards replacing the existing energy infrastructure. As far as like energy infrastructure goes, part of the plans that SoCalGas and Southwest Gas and National Grid have is to take this hydrogen that they claim is going to come from green hydrogen, but through the transition, it's going to start with blue hydrogen. They're going to inject that into the natural gas pipeline. And after you inject more than 5% of hydrogen into your natural gas pipeline, you end up with more embrittlement, which is something I think someone said in the comments of the chat. So yeah, thank you for pointing that out. So I think that hydrogen is sort of a way that the industry is trying to show that they're transitioning without actually doing much transition. So when green and blue hydrogen are compared with renewable energy just itself, like let's just look at solar and wind, take the energy from that and use it for electric powered vehicles, electric powered infrastructure. When you evaluate these against that existing infrastructure, it is actually creating much more emissions than it saves. It makes a lot more sense for you to take that those renewable energy sources like solar and wind and put them directly towards a electrical purpose versus using them to create a different form of energy that then goes into creating electricity. It's like, I guess like logically, I can't make that work in my head. And it's sort of the same thing even with methane. Like it would be less carbon intensive for you to just have methane and use that methane as a gas versus have methane, put it through this process, superheat up a tank to 700 degrees, and then create a hydrogen, which then has to go into a truck that's going to get trucked to where like the vehicles are. Those vehicles are going to fuel up, and now they're going to create an electricity for that vehicle. I guess like I'm trying to explain that. Yeah, it's just use the thing that you started with. Like, why create all these derivations for it instead of just using these fuel sources or electricity sources as they were? So here's what you can do. Push back on the narrative that hydrogen is cleaner than gas. As as far as permitting goes, there I'm trying to remember how many permits are out there. I don't want to give you a wrong number. I would say just push back on that narrative that hydrogen is cleaner than gas. Create a quick method for identification of new hydrogen permit applications, and create like a process so that whatever group you're working with, whatever organization you're working with, how are they responding to it? How are they towards the carbon emissions issues? And then, yeah, I think like really what I would hope that you pull away from this is that hydrogen is odorless, but it doesn't necessarily pass the sniff test. I think that was like my clever joke for the end of this. So thank you. I will now take some questions.
Thank you so much, Ashley, for the presentation. And I'm going to put a link in the chat to where the replay can be added as well. And there are a few questions that have come up so far. So I'll just scan through the chat a little bit and see. Get my video working here too. Hey, there I am. Yeah. So, and also feel free, anyone, to put your question into the chat again, or add a new question to the queue.
Oh, thank you, Andreas.
So one question that came in from Harv was, oh, actually, I don't know if that was a question. I think that was just a, well, okay. And I'm going to make sure I didn't miss anything, but the one that I see right now, I actually wanted to ask if you can talk a little bit about the incentives for companies to create so much waste, just in terms of using fuel to create something else. Like, I'm assuming that there's a systemic issue there. It's not just some evil people being like, haha, let's find a new way to use more energy. So like, why is that happening in the economy?
I think a lot of people look at Europe as a good example of hydrogen use. So Europe has been developing hydrogen for some time, and again, like the marketing around it has been that it's a clean burning fuel, and so it does help meet some of the standards that are out there. I think the US is it's being pretty convinced by that, and so people are creating these companies around hydrogen or transitioning their companies towards hydrogen because the US is making all of this funding available for it. And like funding does not get created in a vacuum. It gets created through backroom conversations, gets created through connections. And so if you want funding from the government, you more than likely know someone within the government who has the ability to create bids that you can apply for. So I think the groups who are encouraging this on the US government side are the groups who ultimately will be applying for those bids in order to like rebuild their infrastructure. Automotive companies who would like to build up new automotive facilities and production facilities. These groups are seeing that there's movement towards a green initiative, and they're looking for something where they can kind of do the same thing that they've been doing, put more funding towards R&D, and also increase the amount of like assets that they have for their own company too. I don't know. Yeah, I think
that makes a lot of sense, and it goes a little bit more than just Harv had a good response in the chat about that they can market their products as cleaner and greener, but thanks also for clarifying that that also means that they could meet certain requirements, so they're incentivized by the law, maybe not seeing how the energy is created. They're only looking at the emissions when it's actually being used.
Right. And that's why this is greenwashing, right? Is that it is a process that ultimately creates more carbon emissions, but it's marketing itself as something that reduces emissions, which is just simply not the case.
Thank you. That's really clear. All right. Any other questions going through? Lots of comments, lots of good comments during this as well.
I do see one question about, oh, Andreas also has a question.
All right, I got to them. Bob says, are there any advancements in the process of creating hydrogen through electrolysis?
Electrolysis.
Electrolysis.
Yeah, so and that's sort of the electrolysis process is really what we're looking at here. So typically for electrolysis, it does require precious metals in order for it to be effective, especially within a fuel cell. And so that was some of the limitations that existed for hydrogen fuel cells for a long time, was that because you need this precious metal, it's more expensive and it's more costly to build as an infrastructure. I do think there's been movement towards changing the metals that are necessary for the electrolyte in order to reduce the need for mining and things like that. But as far as like what those metals are, I really don't know. I think that they have to be getting more scalable because I am seeing more of these cars on the road. So maybe their production process has been made more efficient. They've built up larger factories for it. They can get a larger output for it. But I don't know the specific details of what changes have been made for the electrolysis process.
Andres has your hand raised. Do you have a question?
Yeah, and super appreciate that, Ashley, and thank you all for setting this up. I just had a kind of a two-part follow-up question on embrittlement. So essentially, from what I'm understanding, embrittlement by mixing hydrogen to these pipelines, it essentially kind of wears down the infrastructure, essentially enabling these pipelines to continue maintaining their infrastructure. Is that kind of correct from what I understood?
Oh, this is a great question because I love talking about embrittlement. So embrittlement, I do think it's going to change like the sort of like when I say like life cycle in this sense, I'm thinking now more about like the life cycle of like, okay, you're using something and you can use something only so many times before it breaks. Same thing for like a car handle. Car companies will test the handles like 1,000 times to verify that they will last for the lifetime of that car. So embrittlement in this sense, yes, there's probably going to be life cycle wear to the inlets for the pipes that are necessary, or just like the repairs that go around it. But there's also metal embrittlement. So when it comes to a pipe itself, or like metal being exposed to these elements, because hydrogen is so small, it's able to, within the microstructure of that metal, it's able to seep in further. And so through doing that and through changing of temperatures, rapid expansion and decompression, it actually makes that metal more brittle as like a metal characteristic. So when it comes to like the apple, oh my gosh, this is what happens when you put me. So when we're looking at a pipeline, what they're talking about for embrittlement is that after some time of being exposed to these properties that are wearing down on the metallurgical properties and or like characteristics of whatever medium they use here, eventually it's going to start creating leak paths. And even a tiny leak path will allow for hydrogen to get through because of it being such a small molecule. So I think that that's some of the risk with this, is that for methane, with it being a CH4 molecule, carbon is just a significantly bigger molecule. I think like there's still opportunity for methane leakage within these pipelines, but because hydrogen is able to seep through more easily, it creates more opportunity for leakage through that metal.
Got you, and that's super helpful. Then I kind of had a part B to that, if I understood the leakage part correctly, and it kind of goes back to like hydrogen hubs. Through these like processes, I mean, is there an understanding a little bit about what like localized harms where these hydrogen hubs will be like located? Is there like more exposure to spillage or any like study on that a little bit more?
I'm sure there is. I just personally don't know. I did see, I was at a conference with Last Chance Alliance the last couple of days, and they showed an example of what happens when a carbon capture pipeline has a small rupture. And even with a small rupture, it releases this super compressed, super liquid carbon out into the atmosphere, and then it just falls onto the immediate surroundings and the land that's around it. Understanding the impacts of that, I think, is crucial, but I only had so many slides, so that's going to be the next presentation, but thank you.
Super appreciate that. Thank you.
Yeah, no problem.
We have a question from Sarah asking if hydrogen for storage is any different than hydrogen for energy?
Hydrogen for storage is different than hydrogen for energy. It's the same hydrogen. Yeah, I wouldn't say that there's a big difference per se. I mean, hydrogen storage is going to be used so it can transport it between infrastructures, especially since like pipelines don't exist for hydrogen right now, which is part of like why I think they want to inject hydrogen into the pipelines. Yeah, that's sort of the best answer I've got for that. Sorry.
Cool, thank you. Patty asks, can you speak to the loss of energy potential as you move from one fuel to another to electricity?
Totally. Yeah. I mean, there are always going to be inefficiencies within like a transfer process or within an energy creation process. So for example, it takes 9 water molecules to get to the hydrogen molecules that are necessary for hydrogen production. So that means that there's a 9-to-1 ratio of water input to hydrogen output. So right there, that's a major inefficiency in the process. But yeah, between that and fuel cells also have inefficiencies that are going to lead to energy losses. When you look at that on a broad scale, I think you can start to see that like those numbers like really start to add up, like between the losses from that water and the losses between creating the hydrogen and then putting it into like the fuel infrastructure that's going to then fuel the car. There are leakage opportunities there. There are leakage opportunities from the car itself. So there are all these ways that it's like digging down at like the supply that you're trying to create. And when you try to scale that to like a full country, you can see that, yeah, it ultimately, it just leads to a very inefficient process.
Speaking of scaling, Jean has a question. It says, National Grid and other utilities are talking about 100% hydrogen in their distribution lines into people's homes and stoves. In addition to the emissions and waste concerns, is this even feasible?
I have no idea how they plan to do that. Yeah, I really don't know if it's feasible because it hasn't been proven yet. Like as a technology and as a scalable technology, it's just not something that's like being done en masse. And so for them to say that they're going to do this for all these homes, it's like they're just creating a vision for you to look towards for hydrogen. They haven't actually created that solution yet. Maybe they're developing it, but it's on a small scale, and those development tests have been like, you know, there are problems all the time with development, and it causes delays, but it also, you know, it creates problems that they then have to go out and solve before they can deploy this, which is why it's taking so long for hydrogen to even get scaled. Like I remember I was looking at hydrogen fuel cell vehicles and the comparison of them to electric vehicles and to just classic ICE vehicles back in 2017 when I was still in college studying cars. And so hydrogen has been a hot topic for the automotive industry for some time, and yet they still haven't been able to make this something that can be statewide. I think most of the hydrogen vehicles that exist right now are only in California. Yeah.
Thank you.
Can you burn it to cook eggs?
Yeah, can you burn it to cook eggs? That's a good question.
Hydrogen does burn. If it's got heat, it'll cook some eggs. I'll tell you that.
So there's also some articles have been shared in the chat as well. So folks, yeah, feel free to go through and collect those. And let's see, does anybody else have any questions? Someone said, doesn't burning hydrogen emit a large amount of nitrogen oxides?
I think that depends on the gases that it's mixed with. Nitrogen is it's like a neutral gas. So nitrogen is something that they like that will get injected into like food to keep it fresh for longer. So I think it really depends on like, are they mixing nitrogen, the fuel companies, are they mixing nitrogen into their pipelines already, and for what purpose? and there's no way to like really filter that out when it gets to the point of burning. So if they have been injecting nitrogen into that pipeline, then ultimately when it does get burned in a gas stove or something, it's going to get burned too. But that really is dependent on like the mixture of gases that are within that pipeline. It's not that like hydrogen automatically creates a nitrous oxide molecule as a result.
Jessica asks, how do the risks compare if the pipelines or other containers are made from plastic as opposed to metal?
Yeah, I think that really does depend on like the polymer characteristics of it, or like the inherent material characteristics of it. Polymers are pretty great because they have the ability to be more flexible. So metals are like quite brittle. If you slam a hammer against another hammer, it could crack that hammer. Whereas with plastics, you can bend them a lot more, you can stretch them, all that sort of stuff. So it really depends on like the type of plastic that's lined in the pipeline. If the pipelines are being rebuilt, but I don't know what type of plastic itself would be necessary to prevent embrittlement, and embrittlement can happen to plastics too. They're not agnostic to it.
Sarah is asking, given that the major new incentives for hydrogen in the US are hinged on carbon intensity, do you have thoughts on considerations that need to be included or discussed when modeling hydrogen life cycle emissions?
Modeling. Oh, sorry, that's my dog. His name's Apollo. New incentives are hinged on carbon intensity. Considerations that need to be included or discussed. Yeah, I mean, I think trying to ensure that the full life cycle analysis is being performed for this is a really good first step. Because that's sort of like why the marketing for this is working so well, I think, is because it's primarily around like the output of hydrogen is water. But if you look at that full life cycle, it is carbon intensive. So really just making it clear that the full life cycle analysis is showing a bigger truth to hydrogen than just like what is coming out of the tailpipe of the car, I think is really helpful. But I don't know what other considerations would be necessary.
Does anybody know of, or like what are the campaigns or organizations that are focused on this currently? And what are the, kind of like, where are the big front lines around hydrogen development?
I think like existing community organizers are starting to become like more familiar with hydrogen and starting to pick up on this as being like a big distraction from the oil and gas industry to point towards this and get the public on board with it. So like one of the groups that was at the retreat, Last Chance Alliance, they are definitely like, yeah, and Ohio River Valley Institute, they're doing it too. Through creating more education opportunities for people to understand what is hydrogen instead of just this tiny molecule. It is this like full system of different production methods that lead to carbon emissions. If we can improve the communication around that and the understanding around that, it would be helpful, because I think with hydrogen, it's one of those things where to help people understand why it's such a big issue, you need to tackle like the 4 other issues that exist within it first, and like help people understand that and explain to them why that's an issue too. So this is like one of those things where it's like such a layered cake of problematic concerns when it comes to like eco-justice that it makes it difficult to like fully like taken on as a subject. It requires a lot of context behind it.
Great.
Hydrogen replacing O2 in our air. I don't think that that's necessarily a big concern that I have. I don't think that humans are like more inclined to ingest hydrogen than oxygen, especially since like hydrogen is such a non-dense molecule. I think it's gonna want to have a tendency to like float. instead. So I wouldn't be concerned about accidentally like asphyxiating on hydrogen or something like that. I don't think that's going to happen, at least.
Have you found any good resources online that translate the technical information in an accessible way?
Oh, this presentation will be great.
Yeah.
I mean, like, and I think that's like part of like the reason why I wanted to talk about this. There's a great article that Matt Kelso with the FracTracker Alliance published regarding hydrogen as well, that I would point people towards. But yeah, as far as like breaking down this process into all of its components, I'm just not seeing a lot of work being done around that right now. So yeah, if you're looking to publish more things about it, hit me up and I'd be glad to provide some of these resources.
Thank you. I'm going to put the link again in the chat to where you can watch the replay. And I also want to invite folks who want to talk about this to join Halt to Harm Network and leave a comment on this event. It'll be a good way to kind of see who in the network wants to continue a conversation about it or share resources, and we can also try to compile some stuff. Sarah, thanks for sharing that link as well. Yeah, a lot of us here who are already in Halt to Harm Network, so we can connect. And if you're not yet a member, definitely want to invite you to create a profile.
I'm going to do that. And you should too.
Great. So any final questions or any final things you want to say, Ashley?
Yeah, well, if you want to get in contact with me, I'm with FracTracker for another month. So my email is kosak@fractracker.org. Alternatively, you can find me on LinkedIn or ashleykosak@gmail. And yeah, just feel free to reach out with any questions. I love talking about some of these like more technical topics. Yeah, I would love to chat more about it. Thank you everyone for coming. This is so cool. I think this is the biggest meeting of people I've ever talked at before. So I really appreciate your time.
Yay. Yeah, thank you so much. This is fantastic. You're getting a lot of praise in the chat about the presentation and the way that you distilled this information for us. So thank you.
I appreciate it. Thank you, everyone.
All right. Well, we're going to wrap things up, and I just want to give a final thanks, and we'll send an email with a follow-up. You're also going to get a quick survey, so please let us know what you think. Bye.
Bye. Thank you again. Have a great Friday and weekend.
Yeah, you too. Bye, Ashley.